Hello, welcome back to part 3 with KNN. So let's go ahead and choose the album method to pick a good K value. So first I am gonna declare a variable called error rate, and I'll set that to an empty list. And you're gonna know why would I do this. Okay, so to pick the good K value, I want to see from k equals to 1 to the maximum k number. I want to see in this range which one has a lowest error rate. Then that k value will be a good pick, right? Basically, that's what does that mean, right? So to go through with the range, I will deal with that with a for loop. So for I in range, the range will be from k equals to 1 to the number I want to, the k value to be the maximum is, maybe we can try 40. Okay, fair enough. And what we're gonna do first thing is KNN k neighbors classifier, because if you do remember that we have the argument that is called k neighbors, and in the previous example that is equal to 1 when k is equal to 1. So in this one, what should I pass here? I. Okay, so I. In the second step, fit that into x train and y train. Okay, and then we do the predictions. To distinguish this one with the previous one, I would like to add the underscore I here to make the difference, to make it more clear. Okay, and dot prediction. Oh, sorry, predict. And what should I pass here? The testing part. Okay. Now it's time for us to deal with the error rate. I want to know what error rate do we get for each of the k value that I select. So so far the error rate is just an empty list. Okay, so how can I add the values to my empty list? That's a list. So which method should I pick? Append. Okay, so what should I append? Error rate. What is the error rate? How can I do with that? I want to count the numbers of the prediction is different from my y-test, right? Does that make sense? So and I would take the average number of that. So numpy.main, the condition will be pred underscore I that is not equal to y-test. Does that make sense here? Okay, so that will be my error rate. Okay, we can take a look. It should be a list of numbers. Yeah, we got a list of numbers: 0.07, 0.09, 0.05. But you know, visualization is always better than just look at these numbers. Okay, it's hard for us to recognize or see what's going on here. So why not use the strongest feature for Python? We do the plotting. Figure size equal to, because we have 40 selections here for the for loop, so I will make my fixed size a bit larger, and then I start plotting. What should be my x? X is my k value, right? So it's from 1 to 40. And what is my y? Y is the error rate. What else can I add on? Or maybe I set the color, set that to blue. And maybe ls, the line style, I would say that would be dashed. Okay, you can also do like this, right? Do you remember that? And marker, let's say lowercase 0, oh sorry, 0, lowercase o, and we can set marker face color to red, marker size to 10, a bit larger, okay. And for the plot, don't forget about the title, okay, that's the most important thing. So this one I will call that error rate versus p-value, okay. And we have x and y, so x will be, just call that k, plt the y label. Okay, so that is my graph. Let me add on a grade. Okay, so oops. Okay, so this is my graph. The error rate versus k-value, you can see on the horizontal line, the x-axis, now this is representing the k-value, okay, and the error rate is on the vertical direction. So for the previous example, we pick k equals to 1, and for this one, the error rate is 0.076, not a bad number, but we have some case that is even better than this one, right? This one k equals to 2, a bit higher. K equals to 3, not bad. 0.05, it's not bad. So here we can see that after k equals 23, yeah, when k is larger, bigger than 23, the error rate, it just tends to hover around 0.05 to 0.06, right? So let's retrain the model with that and check the classification report. Okay, so this time what I'm gonna pick for k will be 23. So KNN equals to I can do copy paste, but I want you to memorize which method should I call, so I'm typing that all the time. So I hope you're doing the same. Okay, and neighbors classifier. This one, and then the school neighbors, set that to 23. Okay. Okay, and fit will be X train, Y train. And next, prediction is equal to KNN dot predict. And what should I pass in my parentheses? Yes, X test. Okay. And let's print something. Print. Say with k equals to 23. Print. Maybe next line. Print. We want this confusion matrix is based on my y task and my predictions. Okay, print next line, print classification report. Okay, it's also based on y test and predictions. Okay, let's see. This is my report. You can see the result, 0.94, 0.92. This is k equals to 1. So the number that I pick here, k equals to 23, is better than k equals to 1. You can select other numbers. When you look at the plot, you think, oh, that should be a good choice for me. So then pick that one. Okay. So that is all for KNN with Python. I will send you the project later on, so please do the practice. Thank you, and I'll see you in next lesson.